Buenos dias. We are about 1.08 meters away from the side of the house. 1.08 meters away from the side of the house. That would be the equivalent of the sun radiating its light onto a tiny insignificant speck of dust that would be on that wall. That is the equivalent, the same ratio as the sun shining on us from 150 million kilometers away. The same ratio, proportionally correct. If we move back to 2 meters and 16 centimeters, 2.16 meters, we could now use a 2 centimeter diameter bulb. That would be the equivalent of the sun with a diameter of 1,390,000 kilometers, covering a distance of 150 million kilometers and shining on a planet Earth with a diameter of 12,742 kilometers. If we move back to 5 meters, which I have about here, about there. Nope, sorry, marker's there. We are 5 meters away from that side of the house. The equivalent diameter of a sun or a bulb that we're going to use would be 5 centimeters. 5 times 108 is 5.4 meters. This is the proportionally correct to the sun with a diameter of 1,390,000 kilometers shining on a planet Earth with a diameter of 12,742 kilometers at a distance of 150 million kilometers. If we move back to 10.08 meters, which is where we're going now, you can still see that light, and it's during the day. This is now 10.08 meters. See that flashlight? Now, from right here, we should be using a 10 centimeter diameter bulb. A 10 centimeter diameter bulb from 10.8 meters shining onto a tiny insignificant speck of dust, Earth still, because it would be tiny. It's the equivalent, it's proportionally equal to a 1,390,000 kilometer diameter sun radiating its light 150 million kilometers onto, you can still see it, onto a 12,742 kilometer diameter planet Earth. So from right where we are right now, we should be using a 10 centimeter diameter bulb. That would be the equivalent of the sun radiating onto Earth from 150 million kilometers. But the bulb in this is 3 millimeters. 3 millimeters. A 3 millimeter bulb, the distance that we would be from that side of the house is 3 times 108. 3 millimeters times 108, which is 32.4 centimeters. That is the equivalent. And we are where we should be using a bulb with a diameter of 10 centimeters. That is the proportionally correct distance from a 12,742 diameter Earth with 150 million kilometers in between that Earth and a sun with a diameter of 1,390,000 kilometers. As you get bigger, as the distance increases, the diameter of the light source increases proportionally all the way up until we get to the sun. The sun, with its diameter of 1,390,000 kilometers, is 108 of its diameters away from planet Earth. It's 108 of its diameters. That is absolutely nothing. When you're looking at a star that has a diameter of 1,390,000 kilometers, when you're looking at that sun, it is only 108 diameters of itself away from us. That is equal to a 3mm bulb being 32.4 centimeters away from this side of the house, which would be about here. So the bulb that I'm using now is 3mm in diameter. This is the proportionally correct distance that the sun is from Earth. The bulb, this flashlight, is about 32.4 centimeters away from the side of the house. That is proportionally correct to our star, the sun, with its diameter of 1,390,000 kilometers, being 150 million kilometers away from a 12,742 diameter planet Earth. And again, back to here, back to 10 meters, and you can still see that flashlight, and it's still during the day now. From right here, to keep it proportionally correct, right, with a sun with a diameter of 1,390,000 kilometers at a distance of 150 million kilometers away, shining onto a planet Earth with a diameter of 12,742 kilometers, from right where I am now, I should be using a light bulb with a diameter of 10 centimeters. But the 3mm bulb is more than enough. There is no way in any dimension that the sun takes 4.6 seconds to radiate its own light, the distance of its own diameter, and it definitely doesn't take 8 minutes and 20 seconds for the sun to radiate its light to planet Earth. It is an absurdity. It's just plain stupid, guys. All right, laters.